So if we want to find the orthocenter of a triangle, we got to do a bunch of different steps. We got to find the altitudes, we got to graph them, we got to find where they intersect, and that's our orthocenter. So first thing I suggest, if we have 3 points, is that we draw our triangle. Doesn't matter what it looks like, we just need a triangle. And then we have to find the slopes of these lines. So the slope of DE is going to be 0 minus 9 over negative 6 minus 3, negative 9 over negative 9, positive 1. Slope of EF is 9 minus negative 9 over 3 minus 12. So it's 18 over negative 9 or negative 2. And the slope of, we should have segment lines over top, DF is 0 minus negative 9 over negative 6 minus 12, 9 over negative 18, negative 1 half. So those are the slopes of those segments. But we want to find the opposite reciprocal. So first thing I'm going to do, or next thing, is I'm going to draw these. Make that C. I'm going to draw from E over to B, and D down to A. And it should intersect here, but it's just a rough drawing. We just want to be able to reference stuff. So if we're looking at, so we've found the slope of each side. We use the slope formula because we can't count. The slope of the altitudes of those sides. So CF, well, we know it's going to go through F. That's 12 times negative 9. And the slope of CF, it's got to be perpendicular to DE. DE slope is 1, so the opposite reciprocal is negative 1, and negative 1 over 1. Then we put it into point slope form. Y plus 9 equals negative 1, that's minus 12. We distribute negative 1, and then we subtract 9 from both sides, so we get our equation to be y equals negative x plus 3. And we do this for all the other ones. E. Point we're going to use is E. 3, 9. Well, DE is perpendicular to DF. DF slope is negative 1 over 2, so opposite reciprocal is 2 over 1. And again, this plug goes in. We distribute to get this into slope-intercept form. We add 9 to both sides. Y equals 2x plus 3. And our last altitude, AD, well, we're going to use the point D, it's 6, 0. AD is perpendicular to EF here. EF slope is negative 2, so this has to be positive 1 half. So again, we just plug in, oops, that's M equals 1 half. We substitute in y plus 6 and 1 half and x. Oh, I got those backwards. That is a y minus 0 equals 1 half x plus 6. Then I distribute, and y minus 0 is 0. I don't have to do much there. And x plus 3. So I have my 3 altitudes. These are my altitudes. Of course, the intersection of the altitudes is where our orthocenter is. So we've done steps 1, 2, 3, and 4. Now 5, we have to find where 2 of them intersect. I'm going to just take the first 2. In slope-intercept form, this equals y, this equals y, so they have to equal each other by a transitive property. So stuff that we've already done. Add x to both sides. Comes to 3. So 0 equals 3x, divide by 3. 0 equals x. And then I have to substitute that back in to get my y. Put it into either one, it doesn't matter, they'll give me the same thing. So I get 2 times 0 is 0, 3, so my point is 0, 3. The last thing I have to do is I have to verify that it fits into one of the other equations, or the third equation. This one is the one we didn't use. Y equals 1/2 times 0 plus 3. Oops, not y. We're hoping that that y is 3. And it turns out it does check out. This is my orthocenter. To find the median, or the centroid, where all the medians intersect, much simpler. All we're going to do is take the average of the 3 points. So for our centroid, we do -6 plus 3, 12 divided by 3, and 0 plus 9 plus -9 divided by 3. So that's -6 plus 3 is -3, plus 12 is 9. 0 plus 9 plus -9 is 0. And we get a centroid of 3, 0. Happens to be the same, doesn't mean that it's going to be.